Hi again. This is our second example for graphing piecewise defined function. And first, to graph a piecewise defined function, you want to identify the domain, okay, for each functions. So the first, for my function x, so x can only be graphed or seen or is defined if the x value are less than or equal to 0. So let me highlight that. So on the x-axis, what are the numbers that are less or equal to 0? This is 0. Am I going to shade the axis on the left of 0 or on the right of 0? Remember, you want to have all the number less or equal to 0. And you're correct. It has to be on the left side of 0. Okay. Then I'm going to use another color. So, and then I'm going to shade this region right here. Why? It's a visual reminder that my lines on my function that I'm going to graph can only live right here for all the x values that are less than or equal to 0. And what I like to do also, I like to draw my visual reminder line like this. Okay, it's a reminder not to cross it over. Since this line is also the y-axis, it also helps. But let me make it a little bit wide. Okay, thick. So I know that my line that I'm going to graph cannot cross it over. Okay, so the line is to sit right here in the domain, in its domain. Okay, so this is the equation. I have y equal x. So what is m? Remember, m is the number in front of x, which is 1. And how do we turn 1 as a fraction? We draw 1 and you write 1. So the rise is positive, so it means I'm going to go up 1. And the range is also positive, it means I'm going to move to the right 1. Okay, where am I going to start? Always start from the y-intercept. The y-intercept is the number being added to the x. So if you don't see any number being added, it's going to be the number 0. So we start at the origin 0. Okay, so I'm going to place my dot 0 right here at the origin. And what am I going to do? I'm going to go up 1 and to the right 1 and then place my dot. Up 1 and then to the right 1. Okay, can I do that? Okay. Uh-oh. Remember, I can only grab the line in its restricted domain, which is on the left side of 0, not the right side. So I cannot continue further. But I still want to build my line. What can I do? Okay, let me erase. So what you can do is you go back to the y-intercept, and then instead of going up 1 and to the right 1, you're going to go down, do the opposite of what you see here. So I'm going to go down 1 and then move to the left. And I place my dot, down 1 and move to the left 1. And keep doing that, down 1 and to the left 1. I think I have no dot, so I'm good. I'm going to stop right here. Okay, so now let me look at when x is 0 on the line of the function. Am I going to have a full dot or empty dot? Okay, but let's first connect the dot with the ruler. I think I forgot to do that earlier. And I put the arrows only on the left. Why? Because there's a restriction on the domain. So no arrow I cannot draw arrows on the right. Why? Because they have to stop. Okay, the function needs to stop here. Because you're only graphing a piece on the function of a function on the specific domain. Okay, so now here, because the line for this function, x can be equal to 0, so I'm going to have a full dot. So let me draw a full dot right there. Okay, so now let's graph the line for y equal 1/2 of x. So where am I going to graph this function? It's only going to be on the function can only exist if the x value are greater than 0. So on the x-axis, what are the numbers that are greater than 0? Okay, they're located where? On the left side of 0 or right side of 0? So I hope you can tell me, okay, it's on the right side. Why all those numbers on the right side of 0 are greater than 0? Okay, so 5 is greater than 0, 10 is greater than 0, and so forth. Okay, and then I'm going to use another color pencil to also shade the region. Why? It's a visual reminder that I'm not supposed to cross over this region. Okay, so I'm supposed to remain in my domain. That's why I'm shading this area. It's my domain where I can live or stay. So now let's build a line. So the slope m is the number in front of x. And what is the number in front of x? The number in front of x is 1/2. So 1 is positive, so I'm going to go up 1. And 2 is positive, I'm going to move to the right 2. And where am I going to start? B is going to be equal, B is equal to, okay, if you don't see a number right there, it's the number being added is 0. Okay, so again, I'm going to start at the origin, and then I'm going to go up 1 and then move to the right 2, and I place my dot. Up 1 and to the right 2, up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. I think I have enough other pairs so I can connect the dot. And make sure you include the arrows on the right only. Why? Because the line is cannot fully continue forever on both ends. Why? Because there's a restriction right here. Okay, at 0. So we only this line can only be graphed for all the x value greater than 0. So now, don't say because this doesn't have the equal, the line under the equality, the equal to 0. Okay, the line under equality. So I have to erase that dot and make it empty. No. So the dot stays empty. Okay, and the reason is, think of it as a full glass of water. You have a full glass of water, right? And then you don't drink any of it. Okay, is your full glass of water going to be empty? No, it's going to remain full, right? Because you have a full dot earlier. So remember, the dots are not two disjoint dots, like I explained earlier. So for instance, here, when the line are disjoint, they're not connected, you have to have one full and one empty. But for the example 2 I have here, the two lines are connected at 0. And because you have a full dot earlier, so it has to remain full, right? So it has to be full, not empty, okay? Why? Because in one hand you include the x value, the other you don't include it, but the x value is still included, okay? So I hope I make sense. So thank you for watching my videos, and I hope this video was beneficial to you. Okay, bye-bye, have a nice day.